Hi students. So today we will see the network model. So where this network model is used. So that is used in a civil construction line, or when there is a assembly line, we are using this network model. So you know the representation of a network model is like this, basic representation like this. So we will cover in detail, but this is the representation. So what is a network? So network is a graphical representation of the project, and it consists of a series of activity arranged in a logical sequence and shows interrelationship between the activities. So how this network diagram is drawn? So for that you can take an example of your, suppose, a ballpoint pen. So what are the different points of parts of ballpoint pen? So this is the main part, or we can say the main body, and suppose there is a, this is a back cover, this is a front cover, and there is a cap, you can say. So these are the parts of a ballpoint pen. So what is when assembling this ballpoint pen, we are placing first refill into that pen. So here refill into the main body, then we are putting the back cover here, then we are putting the front cover, and then we are putting the total cap. So this is the assembly procedure. First, suppose we are putting the refill into the pen, so that is, we can say, the activity A, putting refill into the pen. Then if we are putting the back cover, then activity, that is activity B, then front, that is activity C, and last, that is a putting the cap, that is activity D. So these are the activities in that assembly of a ballpoint pen. So this is a network, is a graphical representation. So we are showing that graphical representation like that: A activity, B suppose activity C. So this is for example, and suppose this is a activity D. So we are joining here. So like that, this graphical representation, this type of graphical representation is known as a network. Then second definition is activity. So an activity is a physical identifiable part of project which consume time and resources. So just I have mentioned, putting the refill into that ballpoint pen body is, we can call it as activity. So that is defined by activity A, B, C, D, whatever. Then event, an event represent the start of the completion of the activity, start and the completion of the activity. So we are showing the activity by this arrow. Suppose I am putting the A is a activity. So before and after there is a node. So here suppose a node 1 and 2. So this A is nothing but the, it is activity, and this is a head event, we can say. This is a, sorry, this is a tail event, this is a tail event, and here this event is a head event. Okay, so an event represent the start and completion of the activity. So this is a event, and this one is a event, and in between part this arrow is known as a activity. Then preceding and succeeding activities. So preceding means previous activity, succeeding means succeeding next activity. So अगर हमारे पास A एक्टिविटी है और A के बाद B एक्टिविटी है, suppose B के बाद C एक्टिविटी है, these are the three activities है suppose. So here A and B, when talking about this A and B, now while this condition B is a succeeding activity of A, मतलब A के बाद B activity आ रही है, succeeding activity means next activity, or we can say A is a preceding activity of B, मतलब B से पहले A activity आ रही है. So these are the preceding and succeeding activity. We will see in the detail while solving the problem. Then path, that is unbroken chain of activities between two events, it is called as a path. Then next is a dummy activity. So an activity which depicts the dependency or relationship over other activity but does not consume time or resources. So it is used to maintain the logical sequence. It is indicated by the dotted line. So the activity which does not consume any time and it is required to maintain the logical sequence. So this activity is known as a dummy activity, and on diagram it is shown by the dotted line. So we'll see a one type problem on dummy activity. The next or last part is a critical path. So it is a longest path on a network that does not allow any delay. So the path which requires the maximum time, so that path is known as a critical path, and the activity lying on a critical path are known as a critical activities. So we will see with the problem. So these are the some basic definition required while studying the network model. So these are network, activity, event, proceeding, succeeding activity, then path, dummy activity, and critical path. So take, this is a problem. So a new water pump is to be developed which is similar to the one already being produced. So we are having a previous data of that pump. Activities and time duration for those activities are determined. Now company wish to determine the critical path, project duration. You are requested to analyze the situation. So here we have to determine the critical path of this project and duration of or time of the project. So here similarly like previous example ballpoint pen. So here this is a 1 to 2 as activity. So 1 to 2 we can say putting the refill into the main body of a ball. Then 2 to 3 that is putting a back cover to the ballpoint pen. Likewise these are the activities and time required. So here this time is given into the week. We can in the problem it may be given into the minutes, hours or week. Okay. So these are the activity 1 to 2, 2 to 3, 2 to 6, 3 to 4, 3 to 5, 4 to 5, 4 to 6, 5 to 6 and 6 to 7, and the time required for completing these activities are given 2483 20438. So these are the times. So now how to start draw the diagram. So we are starting with the activity number 1. 1 to 2 is activity. So I have already told you that this is a head event and tail event, and in between that this is the activity. So suppose 1 to 2, so this is a we can say tail event and head event, and A is the activity. So here 1 to 2, so it starts from 1. So I will start with the head tail event 1 and it is going to the event number 2. So 1 to 2 and there is always forward arrow in that. So this is we can say this is the activity. Okay. Now 1 to 2 we have completed. I will put the time afterwards. So 1 to 2, then 2 to 3 means after 2 there is a 3. So then 2 to 3, then again there is a forward arrow. Then 2 to 6, so means it will start with the 2 and ends with the 6. So you can draw anywhere. So you can draw 2 to 6 here or you can draw 2 to 6 here, no problem. So first we are doing the we can say sample or rough work, and then finally we are doing the network diagram. So here I am doing here 2 to 6 upward side. Then 3 to 4 means it starts with the 3 and ends with the 4. So 3 to 4 always show the forward arrow. 3 to 4 we have completed. Then 3 to 5 means it started from a 3 and ends at the 5. So 3 to 5 again shows the forward arrow. Here 3 to 5. Then next is a 4 to 5. Now it will start from 4 and end at the 5. So I will again revise this and I will take 5 here because we require the forward arrow always. So 4 to 5 here I will show. Then after the 4 to 5 it is a 4 to 6. Now here 4 is here and 6 is here. We cannot draw this backward arrow. So because this is a rule, there must be the always forward arrow. So I will take this 6 here somewhere here. So here this is 2 to 6 already, and now here 4 to 6. So I will draw from 4 and then it is a 6. Now then after that this is a 5 to 6. So I will take this 5 to 6 here, just draw the line. So 5 to 6. So while reaching the 6 there are 3 locations. 2 to 6 you can reach, 4 to 6 and 5 to 6. You can check from the problem. So here 2 to 6, then 4 to 6 as well as 5 to 6 is there. And last activity is a 6 to 7. So from 6 end is a 7 is the activity. Now here we have drawn the network. So first step we have completed. We have drawn the network by which is given in the problem, activities and time duration. Now we will put the time over here. So 1 to 2 time required is suppose 2 weeks. Then 2 to 3 4 weeks. Then 2 to 6 8 weeks. Then 3 to 4 3 weeks. Then 3 to 5 2 weeks. Then 4 to 5 0. So here it is a 0. We can say this is also dummy activity, we can say because 0 time is required. Then 5 to 6, so 5 to 6 3, and 4 to 6 here it is 4, and 6 to 7 8. So we have put the time on the network diagram. Now we have to find out the critical path and project duration. So as a definition, from the definition we know critical path is the longest path on a network that does not allow any delay. So means we have to start with the point 1 and reach to the point number 7, and while reaching point 1 to 7 there are a number of ways or number of routes. So I will show you what are the different number of ways. So here in the diagram you can see, so start with the 1. So first route may be 1 to 2. So you can go from 1 to 2, then 2 to 6 and then 6 to 7. So first route is 1 to 2, 2 to 6 and 6 to 7. Start from 1 and reach up to the 7. So 1 2 6 and 7, that will be the one route. If you go by this route 1 2 6 and 7, so it will take for 1 to 2 time required is a 2, then 2 to 6 time required is a 8, and 6 to 8, oh sorry, 6 to 7 time required is a 8. So here we can write 2 plus 8 plus 8, so that will be the 18. So 18 week is the time required, while if we go by the route of 1 2 6 and 7, then another route is 1 2 3 4 6 and 7. So here 1 2 3 4 6 and 7, that will be the another route. So 1 2 3 4 6 and 7. So if you take the time, so for 1 to 2 2 week, 2 to 3 4 week. So I will write directly here 2 plus 4 plus 3 plus 4 plus 8. So that will become 8 plus 4 12 15 19 and 21. So here this is 1 2 3 4 6 7. So 21 week is the time required. Now there is another route which is 1 2 3 4 5 6 and 7. 1 2 3 4 5 6 and 7, that will be the another route. So I will write here directly 1 2 3 4, then 5, then 6 and 7. If we take the times, so here 2 1 to 2, that is 2, then 2 to 3 4, 3 to 4 3, 4 to 5 0, and 5 to 6 3, and 6 to 7 is 8. Yes, 8. So if you make the addition of this 11 14 18 and 20, so here it will show the 20 week. And there is another route is 1 2 3 5 6 and 7. So that will be the another route. So 1 2 3 5 6 and 7. So you can make again, put the time. 1 to 2 is a 2, then 2 to 3, that is 4, 3 to 5, that is 2, 5 to 6, that is 3, and 6 to 7, that is 8. 8 plus 3 11, 2 13, 13 4 17, 17 to 19. So here it will show the 19 week. So we have developed these routes, number of routes. I will zoom out this. So here these are the different number of routes from which we can reach to the point 7. So here we have calculated the time required to complete this operation. So for first there is 18, then 21 week, then 20 week and 19 week. So from all these, 21 week shows the highest time, or it is also called as a critical time. And this path is known as a critical path, means 1 2 3 4 6 7. So this path is a critical path. If you go by this path, you will require the maximum time to complete all the operations. So we can write the answer is critical path is 1 2 3 4 1 2 3 4 6 7, 1 2 3 4 6 and 7. So this is a critical path, and we can say critical time. So critical time is 21 weeks. So this is the answer of the problem. Okay. So likewise you can calculate the critical path and critical time. So this is a simple method by defining the number of ways. Here we have calculated 4 ways, but in some problem it may be 5 6 ways, and this is one method. And another method is a forward pass and backward pass method. So that we will see in the next lecture. Thank you.